Hello everyone, this is Computer Science A Level 9618. This is paper 33, May, June 22. And this session, I'm going to solve question 9, which is part of the chapter 20, the assembly language. Okay, and as you can see here, the instruction table in front of you has some instructions, opcode and the operand, and the explanation for each instruction. You need to read these explanations carefully for each opcode. And the question here is the address of 500 contains the value 100, and the address 100, this one, contains the value of 20. Now state the addressing mode and the contents of the accumulator ACC after each instruction has been executed. You have some instructions here of the 500, and now the question asks you to identify the addressing mode and what would be the content of the accumulator. To answer this question, you need to review the modes of addressing. You have 5 addressing modes: immediate, direct, indirect, indexed, and relative. Okay, for example, the immediate, the first one, immediate addressing mode, you have these two instruction sets, LDM and LDR hash sign, okay, of 13. That means load, okay, load number 13, this number after the hash sign, to the accumulator. Okay, if it's LDR, that means load the number 27 to the index register. Okay, you will find the explanation in the instruction set table here will tell you, will give you like a help of how to deal with such instruction sets. Okay, let's go back to the question. It says here, the first one, LDM hash sign 500. What's the type of addressing mode? Since we see the hash sign here and it's LDM, okay, so the addressing mode is immediate. Okay, so the addressing mode here is immediate. Okay, and the content of accumulator, since it's the number after the hash sign is 500. Okay, so that means load number 500. So the accumulator value will be the same value after the hash sign. Okay, now the next addressing mode, it says here LDD 500. If you go back to the modes of addressing, LDD here and the value, that means copy the contents of the address 56 to the accumulator. Now this type of addressing mode is direct. Okay, this is a direct addressing mode, and LDD means copy the contents of the address 56 to the accumulator. Now address 56, LDD is written here. That means load the content of the given address to the accumulator. Okay, content of 500 is 100, as it says in the question. So the content of 500 is 100. This is going to be the value of the accumulator. Next instruction is LDI 500. LDI 500. The address to be used is at the given address. Load the content of this second address to the accumulator. LDI, you need to remember that LDI here is indirect addressing mode. The operand contains the address of the value to be used. The operand itself contains the address of the value to be used. LDI 500 here means treat the value found at the address 56 as an address and load its contents. Okay, so as it says here in the question, that 100 is going to be the address, and the value inside this this address is 20. So simply this is an indirect addressing mode, and it has the value now of the 20. This is the value that will be stored in the accumulator. Okay, now to answer part B of the question, it says use only the given instructions set to write assembly language code. So the instruction set here mentioned in the instruction table, only use these instructions, okay, to write the assembly language code to use the constant 20. Now we have the constant 20 as if you are declaring a constant in your programming language, okay. So the 20 here is a constant which needs to be stored. We need to store the value of 20, which is a constant, and then add this constant to the value stored in the address contained in the variable y. We have another variable named y, okay, and this variable y has an address, and this address also will the value in this address will be added to the constant 20, and then the result of adding of this operation will be stored in the variable z. Okay, before we go through this question, I'd like to show this example here from the book. Okay, simple assembly language program. A program written in assembly language will need many more instructions than a program written in a high-level language, as we know, to perform this task, the same task. In a high-level language, adding three numbers together and storing the answer would typically be written as a single instruction. As you can see, in a high-level language, it's very easy to add the variable first, second, third all together and store the total in the variable total. In the assembly language situation is much different, as you know. So we'll start by, for example, LDD, and then the variable, the value on the variable first. As we know that LDD, okay, is direct addressing mode. Okay, so that means copy the content of the address 56 to the accumulator. Okay, and in our case here, okay, he uses the LDD instead of something else, which is LDM. We'll be back to this point. Okay, and then so first will be loaded LDD here. If we just go back to the LDD, means load the content of the given address to accumulator. Okay, not load the number itself. It's a given address. So if it's a given address, we use LDD. Okay, we'll see something different in our question, by the way. So LDD first, so we will load the first the value in the address first here, LDD, and then add the second, and then add the third. What is ADD or add? ADD add the contents of the given address to the accumulator. So you have an address, and the content of this address will be added to the accumulator. That means we loaded the first, and then we will load the content of second, and then load the content of third, and then the total will be STO total. STO here, if we go back to the instruction table, means store the content of the accumulator at the given address. Okay, so it's very simple here that we have labels to start the program, and we have the labels for the variable first, label for the variable second, third, and total with the hash sign, because this is a variable which has a content, and as we know that LDD here is the type of address of direct addressing mode. Okay, now let's go back to the question. Okay, here in our situation, we'll need to put these together beside each other to understand what is happening actually. Okay, now as it says here in the question, use the constant 20. Now, as the question, as the previous example says that this is a constant, so I will, as if defining a label here as 20, okay, 20, then hash contains the value of 20, which needs to be stored. Okay, so the question says that you need to use the instructions, only the instructions in the given table. Since this is a value, 20 is a value here, constant 20, so I'm going to use LDM, not LDD, because LDM means the number itself, 20. Load the number to the accumulator. So I'm going to use LDM, and the number is 20. Okay, this is an immediate address. And then add the constant to the value stored in the address contained in the variable y. So we have another variable y, okay, and also at the end here you'll notice that we have a variable z. Okay, now add this constant to the value stored in the address contained in the variable y. Okay, so when I want to do so, first I need to store the value of 20, the constant. Okay, just to recall the value of 20 here, and then I'm going to use LDI, the address to be used at the given address. Okay, because the question says that there is an address in a given address. Okay, the value stored in the address contained in the variable y. So the variable y that contains an address. Okay, so if we look at the LDI here is an indirect addressing mode. Okay, what is the indirect addressing mode here? It means treat the value found in the address 56 as an address and load its content. So we have a value here, okay, found in the address 56 as an address. So this is an address which points to another location, another address. So they treat the value in the address 56 as an address and load its content. Okay, so what will happen here is to use the LDI because this is indirect. Okay, LDI, it says that stored in the address is contained in the variable y. Okay, so LDI is the indirect address. This is the address here. Okay, so I'm pointing to this address. So the y here is an address as if I'm pointing to this address here. So this is an address. Okay, the content here is an address, points to an address, as the question says here. Add this constant to the value stored in the address contained in the variable y. So variable y has an address. Now the next step is to add this. Sorry, capital instruction add 20. So now I've added the value of 20 constant to the previous value of y here of the variable. We don't know the variable yet. Okay, and then at the end store the result in the variable z or the variable z. So I'm going to store sto all of the previous instructions or the result of the previous instructions in the variable z. Okay, as I said earlier, you need to be confident with the addressing modes, especially these famous instructions for each addressing mode: immediate, direct addressing mode, indexed, and indirect relative addressing mode. Okay, hopefully things were clear. You can also practice some more questions to be confident in such type of questions in the exam.